So in this session, we discuss about creation of a line. So before we do any example, let's give the general form equation of a line. So if A, B, and C are constants, with A and B not both zero, and X and Y are variables, then the graph of the equation AX plus BY equals to C is a line. So we can call this is standard form. Now this can as well be written as I call this one equation 1. So equation 1 can also be written in the form y equals to mx plus c plus b, okay, plus c, this small c, where m and c are constants and m is a gradient slope, while c is the y coordinate of the y intercept. Now, so we have ax plus by equals to c. Now, for this to be in this form, that means we have by equals to minus ax plus capital C. So which means y equals to negative a over b, x plus capital C over b. So when we say y equals to mx plus c, so here m is negative a over b and c is capital C over b. Now, so geometric interpretation of slope and line. So if this is the x and y-axis. Let's say this is case A. And we have a lines of this nature. Then slope is positive. So the line rises upwards to the right. I remember, even if the line is of this form, so this is the same thing. Case B, if this is the x and y axis, and the line is of this nature, or the line is of this nature, then slope is negative. Line falls downwards to the right. Is what we're trying to illustrate. If for this first example, for instance, if you are to get the gradient of this line, you see this is change in y, this change in x. So change in y is, change in x is positive, and also change in y is positive. So that's why we have m is positive. In this case, if you draw a gradient triangle here, change in x is negative, while change in y is positive. So gradient is negative. Similar to this, change in y is positive, but change in x is negative. So then that will give you a negative value. Now see, if this is the x and this is the y axis, and we have this as the line horizontal, or it may be this line. So horizontal line or lines have gradient 0. You see, said gradient m is change in y over change in x. So for horizontal line, all changes in y is 0, and then change in x is some value. So then 0 over any number is always 0. So then for horizontal line, the gradient is always 0. D, if this is the x and y axis, now if we have vertical line, so vertical lines do not have slopes. So vertical lines have no gradient, because you see by definition, m is change in y over change in x. So change in y is some number, x is not changing. So this thing is undefined. So this makes vertical lines to have no gradient. And then if this y-axis, x-axis 0, if I have this line and I have another line here, such that this line and this line are parallel. So for parallel lines, slope of line 1 equals to slope of line 2. So if the slope of this one is m1, this one is m2, then we are saying that m1 equals to m2. And then f let's say this is one line, and then this is another line, such that the two are meeting at 90 degrees. So slope of this one, m2, slope of this one, m1. Now for perpendicular lines, m1 times m2 is -1, but the product of the gradients of the two lines will always give you -1. And then given an equation of a line, you can always find its gradient by simply rewriting it in the form y equals to mx plus c, and picking m as the gradient. Now, for instance, e.g., given 4x plus 3y equals to 12, then 3y equals to minus 4x plus 12, which implies y equals to minus 4 over 3x plus 12 divided by 3 is 4. M equals to -4 over 3 is the gradient. Another example, if you are given equation of a line to be, say, 4x minus y equals to 10, equal to say 14, then y equals to 4x minus 14, which implies gradient is 4. So that is how you can identify a gradient from a given line. It's as simple as converting the line in the form y equals to mx plus c, then pick the value of m. Thank you.